Chegou a hora do nosso bate-papo com os especialistas e executivos globais da Esri, direto dos Estados Unidos. Vamos entrevistar Adam Pittman, que é Head de Agronegócio e Recursos Naturais da Esri, e o PhD pela Universidade do Texas, Elvis Tacol, que é engenheiro de soluções na Esri. Vamos tratar aqui da importância da Analytics na agricultura, com ênfase em Big Data e Internet das Coisas. Teremos como chave para facilitar o uso da Analytics aplicado aos problemas de negócio e a plataforma da Esri, em especial o ArcGIS Living Atlas e o ArcGIS Pro, e as soluções em SaaS. Contamos também aqui no estúdio com a presença de Antônio Vilela, que é Country Manager da Esri para o Brasil. Seja muito bem-vindo, Vilela.
Obrigado.
Agradeço a sua participação e apoio nessa dinâmica de entrevista que vamos realizar. Vilela, nessa edição, a temática do AgriSummit é inovação e sustentabilidade. Nesse sentido, conta um pouquinho da visão da Esri sobre esse balanço entre preservação dos recursos naturais e a produção agrícola e como os sistemas de informação geográfica podem contribuir nesta equação.
Ótimo. Seabra, muito obrigado pelo convite, primeiramente. É um imenso prazer estar com todos vocês aqui novamente. Eu participei, tive a sorte e a honra de participar de todas as edições do AgriSummit até hoje e fico contente de ver essa evolução deste evento, então, e mais ainda, obviamente, da comunidade cada vez mais madura na indústria do agronegócio do Brasil. Então, é uma grande oportunidade acompanhar todos os projetos fantásticos que os nossos usuários produzem e entregam através do nosso sistema ArcGIS. Muito pertinente a sua pergunta. Creio que pode servir, inclusive, de introdução à conversa que a gente vai ter o bate-papo com o Adam e com o Elvis. Enfim, não é novidade. A gente vive num período muito crítico em que todas as atenções estão para as mudanças do clima. Há algumas semanas, inclusive, o novo presidente dos Estados Unidos reuniu, creio que foram 40 líderes mundiais para debater este assunto. Então, este é o verdadeiro propósito do nosso trabalho. Balancear os sistemas que são produzidos pelo homem e a natureza. Então, o GIS, ou o SIG, como você mencionou, ajuda na resolução destes tipos de problemas mundiais. E é uma parte fundamental para a resolução. Então, respondendo objetivamente à sua pergunta, Felipe, entendo que o GIS ajuda diretamente em 3 pontos, o balanceamento da produção agrícola e a preservação do meio ambiente. Ponto número 1, a tecnologia GIS está sendo aplicada à agricultura de precisão para alimentar o mundo sem desperdiçar recursos preciosos. Então, ela processa grande volume de dados sobre o solo, clima, topografia, fertilizantes, pragas, bem como mede o impacto ou compara com o impacto da legislação, regulamentação, o maquinário agrícola e a demanda do mercado. Ponto 2. Tecnologias avançadas como sensoriamento remoto, drones, inteligência artificial, o aprendizado de machine learning. Então, estão adicionando muito volume de dados, seja em tempo real ou não, ao GIS. Isso apoia na visualização, análise, captura da realidade e na solução, obviamente, de problemas. E por último, o terceiro ponto, a análise geoespacial fez com que todo o oceano fosse mapeado em 3D com dados sobre indicadores chaves como temperatura, salinidade, oxigênio e níveis de nutrientes. Então, neste momento, precisamos usar o que há de melhor na ciência, design, pensamento crítico, pensamento sistémico, para enfrentarmos os nossos maiores desafios ambientais. E a tecnologia geoespacial integra todas essas abordagens, bem como vários tipos de dados, e nos permite olhar para este problema de uma forma holística. Então, geografia, como a gente costuma falar, não é só colocar um ponto no mapa, mas é entender explicitamente as relações entre pessoas, lugares, políticas, práticas. Então, em suma, Felipe, o GIS pode contribuir muito para que sejamos produtivos no setor agrícola, usando menos e melhor os recursos naturais, plantando e colhendo na melhor época, para cada tipo de cultura, de acordo com todas as variáveis pertinentes, como solo, clima, fertilizante, enfim. Então, além de ajudar na cadeia de produção e rastrear e certificar os seus produtos, demonstrando assim que os mesmos são produzidos de forma sustentável para a população em geral.
Excelente, Vilela. Obrigado por se juntar mais uma vez à maior comunidade GIS do agronegócio brasileiro. Vamos agora nos conectar com Adam e com Elvis. Bom dia, Adam. Obrigado por estar aqui conosco nessa manhã, participando do AgriSummit 2021.
Thank you very much, Felipe and Antonio. It is a great pleasure to be here at the 2021 AgriSummit, talking about some of the things that our Esri agriculture is doing around the world. My name is Adam Pittman. I'm the Commercial Agriculture and Forestry Practice Lead at Esri, and I'm joined by my colleague, Dr. Elvis Takau, who is a solution engineer in our natural resources space, and he is an expert in the field of viticulture.
Prazer é nosso, Adam. Bom, vou fazer a primeira pergunta e, obviamente, relacionada com o que eu acabei aqui de falar um pouco e de introduzir. Então, Adam, explica para a gente como é que a agricultura de precisão está causando impacto na produção agrícola. Por favor.
Well, Antonio, to answer your question, how is precision agriculture making an impact in crop production? I would really say that the technology is accelerating rapidly. Understandably, everything that we do in agriculture has a location component. And ultimately, the places that are advancing the quickest are in the ability to detect and quantify patterns and to make predictions. So obviously the 4 bullets up there, everything we do is location. The things that we want to do in measuring size, shape, distribution, determining how places are related, and finding best locations and paths, those are all important. Those are all things that our farming community around the world is doing. But really, the biggest impact is coming on the ability to more rapidly detect and quantify patterns, sometimes in real time, and make predictions with data sets that we never dreamed of using just a few short years ago. You see a few examples represented here on the slide. The scale at which the ag community is supporting this is extremely diverse. We've got customers that work on a micro level, looking at rows of crops, fields, all the way up to continents, entire continents, of doing suitability assessment or forecasts for crops. So we'll see some more examples here shortly, but there are many ways that precision agriculture is making an impact in crop production. That's a good question.
Excelente, Adam, obrigado. Mas explica pra gente, quais tipos de dados são necessários para dar suporte a essas práticas, aos exemplos que você citou?
So Felipe, to answer that question, what type of data is required to support the examples that I just described? I wish it was an easy answer. Truth is, it's not. At Esri, we support, and as a software company, we do our best to support every type and format of data available. And there's a blessing and a curse with technology today. The blessing is that we have an unbelievable amount of information to work with. The curse, that we have an unbelievable amount of information to work with. And the diversity is so wide. It's unstructured, it's tabular, it's bringing in massive amounts of remotely sensed content. And real-time data is actually posing a real challenge to our customers. So let's take a look at a few examples of some of the things that we can do. To help make it easier for the ag community, I would recommend all of you visit the Living Atlas. Elvis is actually going to do a demonstration in a moment on the Living Atlas, so I'll keep my comments brief. But if you are in front of your computer and you want to go to livingatlas.arcgis.com, you can actually visit the Living Atlas and see all the layers of information that are there, the deep learning models that you can access, the applications you can download, configure, deploy on your own, and the many, many, many thousands of data layers that are available. Many of these are global data layers, like the UNESCO Harmonized Soil Data, or the NOAA Global Climate Data. Not only can you visualize much of the information that's there, but you can use it for analysis. So a really great place to start. That's a good question, Felipe. Thank you.
Ótimo. Adam, deixa então te perguntar, qual seria o ponto de partida do sistema ArcGIS que você recomendaria para a nossa comunidade agro aqui no Brasil? Ou seja, quais seriam as ferramentas, aplicações, features que você acredita que podem nos ajudar para começar?
Well, Antonio, that is a good question. Is there a starting place that we would recommend? And I would say it depends. There are many ways in which people use ArcGIS. You can use ArcGIS for data engineering, bringing in information so that you can actually ask questions. People use ArcGIS for visualizing and exploring their content. Of course, spatial analysis is a given. There's well over 2,000 tools that folks can use to do spatial analysis things. But increasingly, we have data scientists that are doing machine learning, AI, big data analytics, and they're using tools like Python, Jupyter Notebooks to actually do that work. So depending on who is asking the question and what they're doing, that's probably the direction I would give for that starting spot. So let's take a look. Since pretty much everybody on this at this conference probably has access to ArcGIS Pro, let's start there. ArcGIS Pro is a professional GIS capability used by millions of people around the world. You could do advanced mapping, visualization, editing, and analysis all through ArcGIS Pro. And you can see some of the things and enhancements that have been made and are regularly made to keep ArcGIS Pro as one of the best tools available. I mentioned Jupyter Notebook integration earlier. Really, this is used for modeling and automation, and it's available in 3 environments for customers to choose. I just spoke about ArcGIS Pro. Jupyter Notebooks is actually embedded in ArcGIS Pro. You can actually deploy Jupyter Notebooks behind your firewall within your own enterprise. You can also leverage ArcGIS Online and SaaS solutions to actually just fire up ArcGIS Online and get into ArcGIS Jupyter Notebooks and begin working with it. There's also a number of galleries that you can leverage for notebooks as starters to get you going. And there's just hundreds of Python libraries with tools and open science capabilities that you can leverage. So I told you, Antonio, that depending on who asked that question, that determined where I would send them to. But data scientists are increasingly using our capabilities and leveraging the capabilities of ArcGIS Pro and the ArcGIS APIs. So for doing things like artificial intelligence, machine learning, and deep learning, those data scientists are using open source and data science ecosystem tools, some of those represented here, and they're actually using R and Python to actually tie into ArcGIS through things like notebooks. And they're using some of the tools and capabilities within ArcGIS to make their life easier within those open science platforms. So those are some of the capabilities that I would recommend for folks to get started. And I know we have a diverse audience, which is why I covered all of those. So good question. This is probably a time where we should invite Dr. Elvis DeCal to actually do a demonstration of some of the things that we can do with ArcGIS. He's also going to show some of the things from the Living Atlas and some of the things that you can do with data. Elvis?
Thank you, Adam. So over the next few minutes, I'd like to talk to you about the ArcGIS Living Atlas as an evolving collection of content that's global, it's geospatial, and it's from Esri. Now, the Living Atlas is accessible to you directly from the desktop client ArcGIS Pro. You can also access it from your web browser via ArcGIS Online. And if your ArcGIS Enterprise portal is configured to access the internet, your administrator can configure your portal to gain access to Living Atlas content directly from ArcGIS Online. So let's take a few minutes and see what this all means. So on my screen, I'm in the Esri Agriculture web portal, and from the app launcher, I can immediately launch the Living Atlas. Now this brings me and gives me access to all of the latest data, content, applications that have been made available to us by the Living Atlas team. Now personally, I like to start in the Browse tab. Here I can immediately get access to and get a sense of what's readily available to me. There are a number of different filters that will allow me to filter by content type. So whether I'm looking for maps or layers or scene layers, or even things like story maps, right? I could also filter in terms of time. So maybe I want the most current content or content and data from the last year. So I have the ability to filter temporally as well. More importantly, I can filter by location. So if I'm interested in data for just the United States, or maybe in this case, I'm looking for data for the country of Brazil, I can filter by location. But I can filter by Esri-only content, or maybe I just want the most authoritative content that's available to me. In addition to these filters, you can also filter by what's trending, by base maps, look at the different types of imagery or boundary layers. But my ultimate favorite filter is the infrastructure filter, because as someone who's working in the agriculture field, looking at commercial agriculture, I would want to filter by agriculture. And that immediately filters my list of data to all the relevant content that is directly relatable to commercial agriculture. And that's a powerful way for you to search and discover content within the Living Atlas. Now, in addition to the ability to browse, I love this apps tab. Now, this tab gives me access to apps that have been curated by the Living Atlas team. These are apps for visual analysis and other types of analysis that you may want to do. My ultimate favorites here, I have to show you the World Imagery Wayback application. Now, this app gives you a unique browsing and discovery experience of all of the world imagery base map layers that go back several years. So I'm zoomed into an area in Sao Paulo, Brazil, in the Araras municipality. I hope I said that right for my friends in Brazil. So this particular field was used to grow sugarcane. So I'm looking at this field currently in 2021, April 8th, but I could also take a look at what it looked like on March 17th. And then I can switch over to February 24th. So just like that, by clicking on this timeline here, I'm able to see this area at different periods of time. So I'm essentially able to go back in time and look at how this area has changed. So that's extremely powerful. And you can see what has happened in terms of sugarcane growth on that particular field at different time frames. Now, drought is a huge issue here in the United States, especially this year has been forecasted to be extremely dry. So this Esri Drought Tracker is one of my favorites that allows me to look at drought intensity on a weekly basis throughout the United States from a period of 2000 to present day. So I can choose any area in the United States. And here I'm focused on Paso Robles in California. And you can see that timeline of drought intensity from 2000 to present day. And looking at this timeline or clicking on this timeline, especially between 2014 and 2017, you can see what the drought intensity was for that area. And given this legend here, you can see that it was exceptionally dry during those years. But you can also see times when it was not exceptionally dry, there was severe drought. So this becomes a really important application in the agriculture area, especially in California, where there's limited water resources, you might want to use this application to essentially evaluate drought intensity throughout the United States. Now, this would be a domestic application that's not necessarily applicable to areas outside the United States if you don't have the data. Moving on, I'd also like to show you a new application called the indicators of the world. Now, I'm showing you my version of these indicators, which I have curated and sort of updated to address my specific area of interest and my specific parameters. It gives you an indication of the health of your area based on the parameters that you configure in a near real-time experience. So I can see what the maximum temperature is, minimum temperature, things like growing degree days for my area of interest. Just to show you how this works, it's a snapshot. It's almost like a dashboard and gives you that executive overview at a glance. But it's also interactive because I can click on GDD and it takes me to my weather indicator site with a dashboard embedded into it that will pull up field boundaries for my area of interest. So I can zoom into a particular field, choose my lasso selector here, and outline that particular field, and I see what the total precip is, the number of days with no rain, the GDU for that particular location. And just like that, I can start to evaluate different locations throughout my region of interest. So I've just picked a new location and you see how those parameters change. In addition to that, I have access to soils. So I can click on the soils tab there and get the Sergo downloader for the entire United States, right? And so I can go in here and choose any basin and pull the soil units for that particular location. Extremely powerful. And then of course we can evaluate drought, and we showed you that with the drought application that allows you to look at drought intensity throughout the US. Another important one is wildfires. With things being so dry, areas are more susceptible to wildfires, especially here in the United States. And so you can get an overview of where we have wildfires occurring. You can get an indication of how the smoke has been forecasted to travel based on those wildfires. So this is another really powerful application. So I just wanted to show you how you can take advantage of some of this content in the Living Atlas and start to use it to make decisions today.
Excelente, Elvis. Muito obrigado pela demonstração. Ada, em relação ao Big Data, como o sistema ArcGIS pode suportar esse grande volume de dados na agricultura? E você teria alguns exemplos? Isso funcionaria com informações de equipamentos e maquinários que estão agora, nesse momento, no campo?
So I guess to answer your question, how does ArcGIS support big data with respect to agriculture? That's best served by a demonstration from Elvis, which we'll get to shortly. But I will do a lead-in for Elvis. When we talk about big data, nowadays we're really talking a lot about the IoT information that's coming in. This would be sensor data, machine data. And that can be millions and millions of records that come in easily. And our customers struggle with how to deal with that massive amount of information. Now, when it comes to ingesting information, we've been able to do that for quite a while pretty easily. And folks have used enterprise technology, GeoEvent Server, to do that. We have a new capability now called ArcGIS Velocity. It's a SaaS solution. It's backed and built on top of Kubernetes. And what that allows us to do is not only ingest information, but also perform real-time analytics and big data analytics. So with that, I will do an introduction again for Elvis to actually show us a quick example of what we mean by that. Elvis?
Thanks again, Adam. It's no secret that big data is transforming agriculture, and the ability of to embrace data-driven solutions is critical to the success of precision agriculture. ArcGIS Velocity is a real-time and big data processing and analysis capability of ArcGIS Online. It enables you to ingest, visualize, analyze, store, and act upon data from the Internet of Things. Let's take a look at an example that illustrates how we're taking advantage of the big data analytic capabilities of ArcGIS Velocity
to store accumulated weather data from our partners at DTN. We'll run some queries and analytics on the weather data retrieved for several farm locations in order to create outputs that are ingested into a JavaScript application to provide crop intelligence. In the ArcGIS Velocity interface, I can create what's known as a big data analytic. The source of a big data analytic can be a feature service from ArcGIS. It can be a cloud service from Azure or Amazon, or a web or messaging service. In this particular use case, we've used a feature layer from ArcGIS, and we filtered it to establish data that represents our growing season. Now, this is based on the plant date for every field of interest. In addition to establishing the growing season, we go on to further calculate growing degree days, frost-free days, and the number of frost days based on the plant date. We could also do things like analyze patterns, find patterns where we have temperature of a certain threshold. We can enrich the data. We could find specific locations or detect patterns in our data that satisfy certain conditions. We can also manage the data, maybe clip out our weather data to only show weather data for a particular area of interest. But then you can start to do things like simple summaries, aggregating points around specific conditions. So the point here is we have a number of different features that we can take advantage of within ArcGIS Velocity. In this case, we run our big data analytic to get a number of different outputs, which we're going to ingest in our web application. So let's take a look at what we have at that stage. Now I have a simple JavaScript web application that's taking as input the outputs of the ArcGIS Velocity Big Data Analytic. So on my screen, you should see a number of different field boundaries that represent different farms. And at the bottom of my application, I've got a number of parameters. So we see the GDU, relative humidity, a couple of others like days without rain or frost risk. All of these are parameters that are coming from the weather data. And as I hover, or more specifically click on a particular field, I can start to get a temperature profile of that particular field. Expanding that box, you can see all the activity that has happened throughout the history of that temperature profile. And as I scroll down, I can actually see events like the plant date, and I can see spray applications and crop emergence. So just like that, we're able to start to gather some crop intelligence from this weather data. And again, as I switch to another field here, you see that those events on the timeline of that temperature profile have been adjusted for the new location that I've chosen. And as I continue to click around and choose different field boundaries, you can see that my precipitation, my cloud cover, my growing degree units, these are all parameters that are changing over time as I click from one location to the other. So let's summarize what we're looking at here. I started with ArcGIS Velocity, where I'm ingesting data into a feature layer. That data is received through an API call using Python, and that I bring that data directly into that feature layer that's stored in ArcGIS Velocity as a big data analytic. Now, taking advantage of ArcGIS Velocity, I can calculate parameters like growing degree units. I can calculate days without frost. And all of those parameters are calculated and outputted as another feature layer, which we're now consuming in this JavaScript web application. Now, this gives our growers who may not have the ability to use tools like ArcGIS Velocity, they will consume those results within a web application like this to give them some intelligence about what's happening in their growing area. And as I click around from one field to the next, you can see the crop type, the acres, and the plant date All those factor in as we calculate the parameters that you can see here at the bottom of the screen. So this is another example of how big data and the power of big data is driving precision agriculture. So with that, I'm going to turn things back over to my colleague, Adam. Thank you for listening.
Well, thank you, Elvis. You covered a couple things there. And Felipe, I know your question there really had a lot to do with big data and working with large data sets. And Elvis just showed two examples that kind of walk through not only how to ingest information, how to work with historical and big data, but also pulling in machine information, which it was a lot of records, and making some quick determinations of what it is we're actually seeing. So there's quite a bit that we can do there. But Felipe, I guess really to answer your last question before we wrap up here, we really see a vision for ArcGIS in agriculture. And as a software company at Esri, it's our core mission, and it has been for the last 50 years, to build the best geospatial capabilities that we can. And we do that with building GIS capabilities. But on top of that, we are growing rapidly. And we have built and continue to develop slimmed down versions of those capabilities in the forms of mapping and location services and location analytics. And what that allows people to do is to take pieces and parts of the ArcGIS environment ecosystem and actually do special small things with those capabilities, embed them into applications like developer solutions. And we see this area as just a rapidly growing environment. With the introduction of ArcGIS Platform as a Service, we see a huge uptick in the agriculture industry for customers that are actually using our platform as a service capabilities to actually build geo-enabled systems. So this is our direction at Esri. For the last 50 years, we've built the leading GIS software in the world. We've really moved into the SaaS, software as a service world, over the past 10 years. And now we're moving into platform as a service, or have really expanded our capabilities in platform as a service. And I really expect these areas to grow. And I expect that our agriculture customers around the world are going to embrace these advancements in technology and use them to do some amazing things. Thank you very much, Antonio and Felipe, for the questions and for inviting us to present. Elvis and I are very excited about what the community in Brazil can do. We're very happy to answer any of your questions, and we look forward to hearing from you. Thank you very much for joining us today. Bye-bye.
Nós que agradecemos, Adam e Elvis. Foi muito boa a apresentação, as demonstrações, as respostas. Obrigado por compartilhar esses insights com essa comunidade agro, essa comunidade GIS aqui no nosso país. Eu faço um convite a todos para continuar conversando com os nossos especialistas que estão nesse momento no chat. Não é não, Vilela?
Não, da minha parte também obrigado, e eu termino como eu gosto de terminar enfim, as minhas apresentações. Agradecendo a vocês, agradecendo à comunidade, continuem a fazer coisas fantásticas e projetos sensacionais com o sistema ArcGIS e contem com o nosso apoio para o que precisarem. Muito obrigado.
Obrigado.